Hey, so after quite some time, I finally got back to making videos. And as this is my very first video in English, please let me know what you think and what I could do better in the future. In this video, I'm going to give an overview of the OpenScan Pi control software, which controls this 3D scanner. For those who haven't followed this project, I've developed a mostly 3D printed 3D scanner, which you can see here. And the whole design and the software is open source. You can find all details on my website, OpenScan.eu, which I will link in the description. The 3D printable files are available on Thingiverse, and there are quite a few great remixes as well. All those scanners could be controlled via Raspberry Pi and this custom software. You can see the Pi and the custom shield here on the right side. This is the Raspberry Pi 3B+. There is a custom shield to control the motors. And also on the other side there is a connector to external cameras, which I will talk about later. Here you can see a custom ring light module with extra strong LEDs and the Raspberry Pi camera V2 with 8 megapixels. And this particular scanner build features two rotational axes. Those allow the camera to take very consistent photos of an object from almost all angles. These photos are then the basis for photogrammetry. And there are various free and also commercial programs available which create a 3D model from those photos. In this video though, I will focus on the control software of the 3D scanner. You can see part of the software here at the bottom of the screen. The software is based on NodeRed and it's running on a Raspberry Pi. It's quite easy to set up, and you can access the interface from any device which is in the same local network. So you can use your smartphone, your tablet or your PC to control the scanner. I've tried to make the design, both hardware and software, as versatile as possible so that you can easily adjust it to your needs. But more on that later. One more note. This video is going to be quite long and I will give you an overview of the software. There will be more videos soon which focus on the hardware side and different use cases of the scanner. After 3 minutes we have already finished the introduction and I will continue with the following points. First, I will say something about the different installation methods and link to some useful resources. Then we will open and update the interface to the most recent version. And finally, I can show you the camera interface where the scanning is taking place. After that, I will show you the settings menu, which is quite important when you want to adjust the software to a different mechanism. I will also show you the recently introduced OpenScan Cloud, which I'm currently working on. This is still a work in progress and I will add new features regularly. After that, I will show you how to access the NodeRed backend where you can see and modify the source code. At the end, I will give you a short summary and outlook on the further development of this project. So here we are at OpenScan.eu, where I try to collect and update all information on my 3D scanner designs. Concerning the Raspberry Pi, you go to the Pi Shield subsection of the page and scroll down to Getting Started. There you can find a detailed user manual and also the precompiled Raspbian image. This image just needs to be burned to an SD card and you need to modify one file with your Wi-Fi credentials and then you're ready to go. I won't go into more detail in this video as all steps are covered in this user manual. There's also a second way of setting up the Pi, which is downloading and installing all dependencies manually, and therefore you can follow all the steps on my GitHub page, where you can see all the dependencies and what settings should be changed. Yes, I will leave a link for this in the description as well. The overall installation process is pretty straightforward, but if you want a detailed video tutorial, just let me know in the comments. And finally, we will now have a look at the user interface. Therefore, you start your Raspberry Pi and wait for roughly a minute for it to boot. And after that, you just need to open any browser on any device which is connected to the same network and open the following address: OpenScan Pi : 1880, which is the port the Pi uses, /UI, which opens the user interface of NodeRed. Here you can already see that there are new updates available, and to navigate the user interface you can use the button at the top left corner and access the different menus. First we are going to the Update and Info tab, and here you see that the Pi will automatically check for updates on each startup, but it won't install anything without your action. It will just notify you that there are new updates available. I highly recommend to leave this switch on because you won't miss out any new features. And as I'm actively developing the software, there are new features every month or so. You see that you are currently using a version from February this year, and the most recent version is from April. So I'm going to read the changelog, what happened since February, which is quite a lot. And you can now install the most recent version by selecting the one here and click on Install Version. This will take 1 or 2 minutes. The Pi will automatically reboot, and you can already see some slight changes on the user interface. You can see here that it displays the hostname and your local IP address, which is only visible for you, of course. You can also access the user manual directly through the interface, and you can see and open the syslog here, which can be used for debugging. Now we're going to open the camera tab, and there are quite a few things happening here. First, the most important field is the one on the top left, where you select the camera input. I'm currently using the Raspberry Pi camera, but you can also use a DSLR camera which is connected via USB, or an external camera which has a different connection, or in the future it will also be possible to use a smartphone. I won't go into detail now, just to show you that the interface is changing depending on which camera you're using. But for now I will just focus on the Raspberry Pi camera. In this first column you can control some general routine parameters like the motor position, the number of images, and the general settings. In the second column you can see the camera details and adjust those accordingly. And in the middle you can see a kinda live preview of what the camera is currently seeing. In the fourth column you can access your past image sets packed as a zip file, and this last column shows some experimental functions. This one here is not essential, and this can also be hidden in the settings menu, which I will show in a minute. And this function is currently being tested before implementing new things into the main user interface. So you can try it out and let me know what you think. Here you can control the positioning of the object, where the rotor will tilt the object. This one will go to the back and the opposite direction. And note that it will take a second to update the preview. The turntable will rotate the object in this direction. And when using my ring light module, you can turn on 4 of the 8 LEDs individually, like so. And what you see that you will need to adjust the camera settings. In this one, the brightness is too high, and we could also just lower the exposure time. And this looks kind of okay. We could now also crop the image a bit because we have a lot of unused space here, which just increases the file size and the reconstruction time. This looks okay. And now we could take, in this example, just let's say 4 images per turntable rotation. And we will deflect to 40 degrees, which means the tilting mechanism will tilt the object 40 degrees to the back, and the end position will be 40 degrees to the front. And in between those two, there will be 3 positions. So one will be at minus 40 degree, like so, and the other one will be at plus 40 degrees, like so. Let's just name the project, which is the Benchy, and hit run and see what happens. You can now see that it's going to the first position, which is 40 degrees back and already turned 90 degrees. Now it's making those 4 images, and after that it's going to the next position at 0 degrees tilting, and again doing a full turntable rotation of 4 images. And now going to the last position at minus 40 degrees and doing the whole turntable rotation again. With an actual proper image set, you would not just use 4 images per rotation. A good number would be like 30, and the distance between vertical positions shouldn't be more than 20 degrees. After the routine is done, you can see all your image files here, and this is the one we've just created. You can click on it, select it, and press download, and it will download all the images to your PC. Here we go. And there's also a file called parameters, where you see the project name and all the settings used in this set. And you can use this parameter file to upload or re-upload the settings. Maybe you once lost your settings or want to restore old settings. You can just do it here. And just recently I've added another great new option to analyze the surface of your object, because most importantly for photogrammetry is a good surface. And I've added this feature, which is kind of an online service, but it's totally free. And we could just zoom in to our image. Let's do it like this. And you can already see that this area here and here, it's a little bit dark, and here it's a little bit blurry. And this might be problematic for the software. I've implemented a function which is called get features. And when you click on it for the first time, you will be prompted to accept of the terms of use, which you can see in the settings menu. which you can find here. Please read it, take your time. It basically says that this is free software and there is no warranty with it, and that by using certain functions, files will be uploaded to my server, stored there, processed there to give you some results. For instance, by pressing get features, the one preview image will be uploaded and processed. Now we just agree to that. Go back to the camera menu and click on get features. This will show you the process about uploading and waiting for the result. This might take a couple of seconds. And here you can see the result where the green dots are, generally speaking, good. They show you the features that the software detected on your object. You can have a closer inspection by opening the image in a new tab. And as expected, the features in this area and also in this area are not as dense as the other areas. Generally speaking, this is still a very good result. You have a lot of features on the surface, but you can see a difference between this area and this area. There would be so much more to talk about at this point, but I will make a dedicated video which focuses solely on surface features and image quality in general. For now, let's go back to the settings menu, and then we are almost done. Here you can access many settings of the Raspberry Pi. As you've seen earlier, the terms of use. And first thing I want to recommend is to use the shutdown button whenever you finished your work and want to power off the Pi. Just press shutdown, wait like 10 seconds, and then only then disconnect the Pi from the power source. You also have this shutdown button in the camera menu. Furthermore, you can, as I said earlier, turn on or off the experimental functions here. Let's see what happened. And now this field is gone. It's just a cosmetic thing. Another function is to turn on or off SSH, which can be used for remote access, for instance via PuTTY. If you do not use this, please turn it off. If you use it, please make sure to change the username and or password, which is still Pi and Raspberry. And there's also a service called SubMa, which is a local file sharing service, and this is enabled by default, but you could also disable this one. This one allows you to access the Pi's file system directly through your PC. Therefore, enable it and open your browser, file browser, for instance this one here, and I've already added this network drive under the address OpenScan Pi, and the username is Pi and the password is Raspberry. It's all standard, and here you can access the file system of your Raspberry Pi. Be careful when making any changes. Probably the most important folder is this one, Home Pi, Shared, UI, Data and Zip. There you can find your image sets and delete those individually, for instance. But just to make sure, be careful when making any changes on the file system. In the second column, you can change and adjust the pin and the motor settings of the Raspberry Pi. Before doing any changes of this section, make sure to unpower your Pi, unplug everything which is connected, then reboot your Pi, and then only then apply the changes. Otherwise, this might damage some of your devices which are connected. Those pins have been set to the standard of my Pi shield, but you could adjust it freely, for instance when using a breadboard layout. At the bottom you can see the motor settings. For the turntable it uses micro stepping, so one rotation is 3200 steps, and this number defines the delay between two steps, so the lower this value the faster the motor will move. Here you can adjust the standard angle that the motor will move on one click. Let's say this one is 20 degrees. So one click here on turntable will move the object by 20 degrees. And those two values just change the speed or the acceleration of the motor. You can play around with those values, see what happens. You could not really damage anything. Same settings are available for the tilting mechanism, and the only major difference is this weird number of steps per rotation. This comes from the microstepping plus the gear ratio between the motor and the tilting mechanism, and this gave this number. That's basically it. And last but not least, you could also use other cameras, but I highly recommend using the 8 megapixel version, which has an adjustable focus, which is absolutely necessary. But you could also use, for instance, the Pi camera V1.3, which has a lower resolution. So at this point we are almost done, and there's only one more thing I'd like to show you, which is the OpenScan Cloud, or at least the beginning of a little cloud service. At the moment I have this free service where you can select one of your files, image sets, and enter your email address, because you need this to get the feedback. Let's say it's this one, and yeah, I've selected the image set and press upload. Again, checking the connection, compressing and uploading the file. This will not upload the full set, but only 3 images of the set, because with 3 images I can already judge whether there will be any problems or not. And you will get a detailed feedback via email. It says the file was received. Okay, then for you that's it. You will just have to wait, let's say 1 day or 2 until I get to review your images. Now I just want to show you how this will look at the back end. On my side, what I will do, I have this interface here, and I've already uploaded a couple of image sets, and the last one here should be the Banshee, and here you see there are those 3 images and also the parameters. And in this case I would say, okay, the brightness is a little bit too high, the contrast is fine, the background is perfect, it's pitch black, the lighting, I don't see many shadows. The focus is kind of okay. I would go a bit closer. No, then this wouldn't be sharp. Surface is not reflective. The texture is great because of those dots. But you can already see that here I've touched the Banshee, removed the chalk spray, so could be better. The overall quality is good. And I will enter some text, looks great, and send the feedback to you. And at this point I will delete those files locally, and you will get an email with one of the images and this feedback rating and the text that I've written here. Okay, there we go. Preparing email, sending email, that's done. and the image set got deleted. There are just 4 more to go. Yeah, I will do some further testing with this cloud functionality, and maybe in the future I could offer, I don't know, some kind of one-click reconstruction service. We'll see how it goes. I will do some more testing, and I'm always happy to hear about your ideas, your feedback. So just get in contact with me via one of my email addresses or social media channels. Yeah, so that's it for the front end functionality at the moment. As I said, I will add features very soon. And now just let's have a look at the backend. And to access the NodeRed backend, it's fairly easy. You have this address, OpenScan.pi :1880, and you just delete the UI stuff. And this is how the program or the interface looks from behind. Here you have the same tabs as on the front, and yeah, it looks quite messy because I'm not a professional programmer. These are just drag and drop elements. So this is a switch for the light, number 1. And here at the end you define what will happen and you connect everything. And the blue ones are predefined UI elements, and the red ones are custom code. And most of the code is written in Python. As I said, my programming is not beautiful, but it's working. So this one here, for instance, is the routine setup of the Raspberry Pi camera. And if you want to change, for instance, the motor movement, you can adjust something here. Just take your time, have a look at it. And I'm very happy. I would be very happy if someone could tell me what to improve and how to improve. And I'm very open for any criticism. Yeah. So that's the backend. And for me, as a non-programmer, NodeRed is a great interface to start programming and to build these beautiful projects. And I'm using it in a couple of other projects, and you can find a lot of great tutorials on YouTube, and the documentation is great, so just give it a try. So there we are, and I hope you've learned something new today. And yeah, this project has been going on for over two years now, and still there's so much more to do and to explore, to discover. My next steps will be working on the larger scanner, which you can already see on the screen, and further improve the OpenScan Cloud. And another quite interesting project is the multi-camera rig. I know that some similar systems already exist, but I want to do some things differently. And in the first step, I will build a head scanner with like 10 or 20 cameras, we will see. And now, as we are all locked down, I have plenty of time also doing some more videos if you like. And yeah, just let me know what you think. I hope you liked it. And if you like the project, it would be super great if you could support me on maybe buy me a coffee or just check out my shop. Yeah, that's it for now. See you next time.